Okay, welcome back to part 2 of trig. So in the previous video, we looked at using trig to find missing sides of our right triangles. The other thing that we can use trig ratios for is to find our missing angles in right triangles. So obviously we know which angle is the right angle, but if we know at least 2 of the sides of our triangle, we can find the other 2 angles, your 2 acute angles. So for example, if you knew that the sine of your angle was 2/3, you can use the inverse operation sine to the -1 of that ratio to get the angle measure. And then we'll just kind of round to the nearest whole degree. So your inverse trig functions are right above your regular trig functions, and they're in blue, or they might be another color on your calculator. But if you hit second and then that trig function, you can get the inverse. So if I do inverse sine of 2 divided by 3, look, I get that 41.81, which will round to 42 degrees. So we're going to do just these remaining problems rather quickly just to practice finding missing sides. So first we're going to look for inverse sine of 15/19. Again, make sure your calculator is in degree mode. So inverse sine 15/19. And rounding to the nearest whole degree, that is 52. Inverse cosine of 4/5. Rounding to the nearest degree, that is 37. And then lastly, inverse tangent of 15/7 gives me about 65 degrees. So let's look at how the equation would start. If you knew that the sine of your angle was 1/2, that means x would be the inverse sine of 1/2, which if you put into your calculator, that is approximately 12 degrees. If you knew the tangent of your angle is 4/3, you would solve that by doing the inverse tangent of 4/3 to find your x value, and that will be approximately 53 degrees. And then lastly, if you knew the cosine of your angle was 4/5, you would do the inverse cosine of 4/5 to get that your angle is approximately 37 degrees. So let's look at those in some actual diagrams and practice figuring out which one you would use. So on 14, I want to find x, and the sides of the triangle that I'm given are the opposite and adjacent. So I remember SOHCAHTOA, if you have forgotten already, the ratio that uses opposite and adjacent is your tangent. So the tangent of my unknown angle x is going to be equal to opposite 51 over adjacent 23. So to find x, I will do the inverse tangent of my ratio, 51 over 23. And when I do that in my calculator, inverse tan 51 over 23, I get about 66 degrees for that missing angle. Moving on to 15, y is the angle I want to find, and I'm given the opposite and hypotenuse. The ratio that uses opposite and hypotenuse is sine, so the sine of y is going to be opposite, 43, over hypotenuse, 48. So to find y, I'm going to do the inverse sine of 43 divided by 48 in my calculator. And not to get a glare for you there, 43 divided by 48, and I get about 64 degrees. And then last one, just for good measure, on 16, C is the angle I'm looking for. I'm given the adjacent and hypotenuse, so that tells me to use cosine. So the cosine of C is going to be adjacent 30 over hypotenuse 35. So I'm going to do the inverse cosine of 30 divided by 35 to find that C is approximately 31 degrees. So again, trig ratios are only for our right triangles, and we can use them to find missing angles as well as missing sides.